Okay, my name is Justin Chu, and this is synthesis of salicylic acid. So the first thing you want to do is assemble your heat source and apparatus. You want to make sure everything is secure, and this is what it should end up looking like. The next thing you want to do is get your boiling flask, and then you want to measure out about 10 millimoles of methyl salicylate, or 1.3 milliliters. Then you're going to add 15 milliliters of 6 molar sodium hydroxide, as well as a few boiling chips. The next thing to do is to run water through your condenser jacket, and then call your professor over to make sure your setup looks good. Then you're going to heat your solution under reflux for 30 minutes after it starts boiling. Once the solution becomes clear, transfer your liquid to a 100 to 150 milliliter beaker. Then you're going to measure out 16 milliliters of 3 molar sulfuric acid. While stirring, slowly add the 16 milliliters of your sulfuric acid to the solution. Then use the pH test strip to make sure the pH falls below 2. If it doesn't, you can add more sulfuric acid. Once the pH falls below 2, cool your solution in an ice water bath for around 10 minutes. Pour your solution over the Buchner funnel and collect the salicylic acid with vacuum filtration. You can rinse it with ice cold water. This is what your precipitate should look like after vacuum filtration. Then prepare 20 milliliters of boiling DI water and add your precipitate to it. Then cool on ice for around 10 minutes. Run this solution through the Buchner funnel and wash with DI water. Once your precipitate is dry, collect it and put it on a watch glass for weighing. Then get a melting point apparatus and add a thermometer. Using micropipettes, collect samples of your product, salicylic acid from benzene, and a 1-to-1 mix of your product and the salicylic acid from benzene. Prepare your micropipettes for the melting point apparatus. Insert the micropipettes into the melting point apparatus as you see here and turn on the temperature. Look through the magnifying glass and record the first temperature at the first drop and the second temperature when the entire sample has melted. Once you are done with your data collection, complete calculations such as percent and theoretical yield.